a mixture of 1s, 2s, and 3s. We'll do those thirds. One can be done in Desmos, 2 we'll do from the graph, and then 3 we can set up the equation, and depending on the equation, either put that in Desmos or solve it. So what is the value of this expression when x equals 2/3? If I were to put this into Desmos with 2/3 in all of the x's, I would get repeating 4s or 4/9. You could have also put in the expression as is with capital X's, made that a slider, and then changed the value to be 2/3. Or changed the variable to a different letter, and then added that slider. But 4/9 was your answer. If you're just writing 4/9, make sure you're use Desmos. The x-intercepts, because they are decimals, you're just going to kind of guess. If we knew what the actual function was, I could put that into Desmos or the calculator and find those. But here, since I'm just given a graph, I'm going to say that this is negative 1.5, something in between negative 1 and negative 2. So as long as you have something between negative 1 and negative 2, you're good. Yeah, I was going to say something else, but that's fine. And then for the other one, basically same thing, but in between 5 and 6. So as long as you have something in between 5 and 6, you are also there. And then for number 3, if it costs $24.93 for 12 gallons of gas, how much does it cost? How much does 19 gallons of gas cost? So I'm looking for how much does each gallon cost? In order to compare, I'm really going to end up setting this up as a proportion. Because I know this total will give me this amount, or this amount of gallons will give me this total. And I need to know how much is it going to cost for 19. So I could set up a proportion and then cross multiply. And then whatever that is, we give us our answer. Divide that, tell me what you get. What do we get? 0.47, because we're looking for cost. If you had known to set this up, so this one was easy enough to solve, but we could have also put this into Desmos and it would have gave us that, but because of the decimal, it would have looked a little weird. I was thinking that we wouldn't be able to get the exact number, but because we weren't like adding, subtracting things in there, then we got the exact number. So if you knew how to set it up, then you could have also used Desmos to solve that. Questions on that? Right, before we get into our notes, I need to mention two things. Because I don't remember if I said this Monday or not. One, if you missed or didn't show me the SOL practice, unless you were absent, Monday, I'm no longer checking those, so it will just be a 0. Make sure you do the SOL practice that's coming up on Tuesday, so that you don't have another 0 in that. And then 2, for your Delta Math, if you are missing those, because they are formatives and we're not quizzing, I'm treating those as regular quizzes. So if you don't do them when we go to take the test, they're not getting replaced. So make sure you are trying them, attempting them, emailing me so I can update your grades. Questions on those two things? Last class we finished Unit 9, so today we're going to start Unit 10 stuff. So everyone should have these notes in front of them. You're going to take down a bunch of notes and then we're going to talk through and do some of these. So start writing as I'm talking. Yes. Yes. Alright, so Unit 10 is a mixture of quadratics and exponential functions. Today we're just talking about the quadratics piece of it. So all quadratic equations are written in the form y equals ax squared plus bx plus c. So that part should look familiar because we did a lot of factoring with trinomials where it looked like that. So a lot of our factoring trinomials were quadratics. We just didn't know that at the time. It's in standard form, ABC order, highest exponent to lowest. When graphed, a quadratic equation creates a U-shaped curve called a parabola. So we've seen this shape before but didn't know what it was called, and now we have a name for it. To the best of your ability, draw these two graphs. And as you're graphing, if in our standard form, the a value, the number in front of x squared, if that number is positive, then your parabola, your quadratic, is going to face up. If it's negative, that is going to face down. And then we also are going to learn some new characteristics about quadratics that are different than just linear functions. One is an axis of symmetry. This is it's invisible, but we're going to draw it in just so you kind of see what it looks like first. That splits the parabola or the quadratic in half, or that divides it into two equal parts. So whatever it looks like on one side, it should look symmetric on the other. To find the axis of symmetry, we're going to use this formula, x equals negative b over 2a. And after we simplify that formula, you'll get something that's x equals a number. And that would show us it's some vertical line. Anyone still need these two graphs? So it has this line that splits it down the middle, and then on this axis of symmetry, there is a point called your vertex. This is either the lowest or highest point. Usually, at this point, the parabola changes direction. Maybe it was going down and now it's going up, or vice versa. So it's the turning point of the parabola, written in the form xy. If it's the lowest point, this is called the minimum, and if it's the highest point, this is called the maximum. Make sure you have these written down off to the side, the x equals, and the, in parentheses, x comma y. And then once everyone has this, we're going to do the first example on the bottom of this page. So this is just going to be a practice on how we can start to graph quadratics, but it's not going to be like graphing it in its entirety. So first we're going to find our axis of symmetry. I'm going to rewrite that. If it helps you, you can label your coefficients and constant as A, B, and C. These are the numbers, not the variables. And then to find our axis of symmetry, we're just going to put in those numbers. It will be x equals -8 over 2 times 1. And then simplify that. What would our axis of symmetry be? -4. And make sure it says x equals, it has to be an equation. Then to find our vertex, we're going to take the number we just found and put it into our equation where all the x's are. Make sure you're using parentheses. And when we get to the test, I need you to show how you set up the axis of symmetry, how you set up the vertex. But whether you simplify that in your head, in your calculator, by hand, that part is up to you. So go ahead and start to simplify this. I'm going to start doing it by hand, but not completely finish it. What would our y value be? So then we're going to write that as an ordered pair. -4, -1. Then we're going to draw a rough sketch of this. So draw in x and y axes. Do a rough sketch of where the vertex point would be. Draw in a dashed line to show where the axis of symmetry would be. And then looking at your equation, our a value is positive. Is this going to face up or down?
Up.
Up. Because it's positive. So from the vertex, just draw a U shape that's facing up. Try to make it symmetric, but it's a rough sketch. It's okay if it's not. So this just gets you used to finding the axis of symmetry, finding the vertex, seeing what the graph might look like, or at least what direction. And then once you're ready, go on to the next page. Let's do number 2, same thing. I'm going to rewrite the axis of symmetry formula up here. If you need to, label your A, B, and C. And then how would I set up our axis of symmetry using our numbers here? So use your B value, not your C value. Negative 10 over B 2 times negative 1. And then if I simplify that, what would our axis of symmetry be? 5. X equals 5. Take that x value, put it into your equation. Again, make sure you're using parentheses with a negative. And go ahead and find your y value. What would our y value be? 2. So our vertex would be 5, 2. Go ahead and draw in that rough sketch. Draw in the axis of symmetry as well. Mine's kind of on this line right here, so I'm just going to do this. Is this going to face up or down? Down, because of the A value. So at that vertex point, draw a U shape that is facing down. We're going to do one problem between 3, 4, 5, 6, and 7. I'll let you guys choose of those. 5, okay. So in number 5, let's do the same thing. when I set up my axis of symmetry, I have a negative b already. So you could put negative 4, or you could just make it positive. Either or, doesn't matter. What's our a value? -1. So then when I simplify this, we would get x equals, what did you say? -2. And then go ahead and put that in for all your x's. What is y? So our vertex would be -2. Go ahead and draw in that rough sketch. Would this face up or down? Down. Do we have any questions so far on how to find the axis of symmetry, how to find the vertex, how we're getting our rough sketch? We're going to skip to number 8. What's missing? C. So in this case, that doesn't really matter. If we were solving by quadratic formula, it would matter, but right now it doesn't. Noticing that it's missing is just good to know that it's missing right now. How would I set up my axis of symmetry? -4 over 2 times -1. Simplified, this would give us x equals 2. Put that in, find your y value. What would we get? 4. Vertex 2, 4. Draw in that rough sketch. Would this face up or down? Down again because the a value is negative. Number 9, what's missing? The b term. So because the b is missing, that's going to be 0. So when I set up that equation, still set it up negative 0 over 2 times 1. But this would just simplify to be 0. So anytime you don't have a b and your b value is 0, your axis of symmetry is 0. Still set up the equation, but also remember that. And then if I put that in to find my y value, what would my y value be? Negative 3. So then if I draw in that rough sketch, my axis of symmetry is going to fall on my y equals, my y axis. I'm just going to highlight over it. And would this face up or down? So now that we know how this generally works, we're going to actually graph this. So go on to the next page. And we're going to start at example 1. So the beginning parts are going to be the same. We're still finding our axis of symmetry, still finding our vertex, but then we're going to talk about domain and range and what that looks like. So I'm going to rewrite our axis of symmetry here. So for number 1, if I set that up, we have x equals negative 0 over 2 times 1. What would our axis of symmetry be? X equals 0. And if I put that in to find my y value, what would my y value be? Also 0. So our vertex would be the point 0, 0. You're going to put that into the middle of your table. Then you can fill out your x's. You're going to go backwards 2 and forwards 2. And then to find your y's, you have a couple different options. You can, one, put each x into this equation and find each y separately. You could do that algebraically or by hand or in the calculator. Or you could put everything into the table. So go into your y equals in your calculator, clear out anything that's there, type in x squared. And then you're going to go into the table, second graph, and we're just going to find the points that we just listed. So we have negative 2, negative 1, 0, 1, 2. Because the axis of symmetry splits in half, once you have your y values, it's just going to repeat. So 4, 1, and then 1, 4. And then you can graph those 5 points. And you should see that it makes that U parabola shape. Draw the U through the points. Make sure it has arrows at the tops. You need at least 5 points. If you want to draw more than that, that's fine. Your axis of symmetry isn't actually drawn in, but I can see at x equals 0, this is split in half. It's symmetric on both sides. Questions on how we graph it before we talk about domain and range? So, some side notes. Domain is your x values. And you're going to read domain left to right, least to greatest. your range is your y values. And you're going to read that lowest to highest or bottom to top. When we write our domain and range, we're going to use our interval notation / you may see it in set builder notation, so I'm going to write both, and so you're going to write that other one. So domain you kind of have to imagine because it's hard to see sometimes. For my x values, this is going up, but it's also slightly going left slowly over time. And over time, that's going to keep slowly going up and left off the graph, off the page, off the board, forever and ever towards that direction. Where would that start? It kept going to the left forever and ever in that direction. Negative infinity. So this would be where it starts. And then on the other side, does the same thing. It keeps going up, but it's also slightly going right. Slowly up and right forever and ever off the graph, off the board, off the page. Where would that end? Infinity. So if it goes both left and right forever and ever, that's going to be negative infinity to positive infinity. What's nice about your quadratics in this class is that your domain will never change. It will always be negative infinity to positive infinity. So this is your interval notation. In set builder notation, you're going to write it like this. Curly brackets. One set of curly brackets. X, then just a vertical line. X, let me rewrite this one here. This weird E, and then like a double R, a capital R with another line through it, and then curly brackets. This reads X such that X is an element of all real numbers. It means the exact same thing as this, that your domain starts at negative infinity, ends at positive infinity, is everything in between positive, negatives, decimals, fractions. But you may see it either way. You have to recognize both. Range, however, we're looking lowest to highest. What would the lowest point of this be? Y value. Lowest Y value. Look at this graph. What is the lowest Y value we see? 0. And if you want to draw in a line at that point to show it doesn't go past this, you could do that. So this is going to start at 0. This point is closed, so we're going to use a square bracket. What is our highest point? Infinity. It keeps going all the way up. So bracket 0 to infinity would be our range, or in set builder notation, starts off the same, curly brackets, y, the vertical line, such that. But this is everything greater than or equal to 0, so it's going to be y is greater than or equal to 0, curly brackets. As you get the hang of this, domain and range will start to make more and more sense. Do we have any questions so far? We're going to graph and find these things for 2 more and then do 1 more page, and then you'll have time to practice. Alright, so for number 2, let's find our axis of symmetry. We have x equals negative 2 over 2 times 1. What is our axis of symmetry? And then finding our vertex, put -1 into all your x values to find y. What would that be? So the first part gives us 1, the second part gives us -2, 1, -2 plus 5. So then our vertex is -1, 4. Put that in the middle. And then fill out your x values. Go backwards 2, forwards 2. And then put that equation into your y equals. Go into your table, second graph, find the values that we just wrote down, and then it's going to read 8, 5, we already had 4, and then 5, 8. And graph those 5 points. And then once you have that graph, what is our domain? It's not going to change. It's the same as the last one. -infinity to positive infinity. Okay. Our range, what's our lowest point? What is our lowest y value of that graph? 4. And you can find it from the graph, or if you look at your vertex, that y value is going to be part of your range somehow. So it starts at 4. Where does it end? What's our highest point? Infinity. You don't have to write this part. I'm just going to write it just so you would recognize what it looks like. Y such that y is greater than or equal to 4. X such that x is an element of all the numbers. Right. And then let's do number 3. How would I set up my axis of symmetry? value be? Over 2 times -1, or you put minus, negative, negative, minus, minus, whatever. Either or doesn't matter, so that our axis of symmetry would be x equals -4. Go ahead and find your y value. What would your y value be? There are some of you that are just waiting for others, but you should be doing this yourself. Put that in the middle of your table, go backwards 2, forwards 2. Put your equation into your y equals and find your y value, sorry. Did you find the y values? Sophia, did you find the y values? Put it in your calculator, find the y values. Charlotte, did you find the y values? Put it in your calculator, find the y values. Matthias, did you find the y values? Put it in your calculator, find the y values.
This is what? This one died.
Okay. It's just that one, it's just that one. Actually, there might be extra batteries over on the shelf. Check that first. If there's not, I'll give you another one. It would be right behind the calculator. What are our y values? Did that work? -5 and 2. And then it's just going to read. So those of you just waiting for answers, you're not going to learn that way. Go ahead and graph those 5 points. What would the domain of this be? same as the other two. And then for our range, where does this start? What's our lowest point?
Negative
Is that our lowest point?
1. Infinity.
Negative infinity. And then our highest point is at negative 1. So because this was flipped upside down, it starts at negative infinity and ends at negative 1. So depending on what way it's facing, that will change your range. So your domain will always stay the same. So the domain in set builder notation will be the same, but in range, this will be everything below negative 1. Find the page that says analyzing. Quadratics, something like that. So not only do you have to find these characteristics from the equation after you graph it or while you graph it, you also have to be able to find it from the graph. So in graph A, find the axis of symmetry. Find the line that would cut this in half, that would split it down the middle, where it's symmetric on both sides. What would that equation be?
X equals negative 2.
X equals negative 2. Because right here I see that this is cutting that parabola down the middle. What about graph B? X equals 3. What is the vertex of graph A? Negative 2, negative 5. That's either your lowest or highest point. We'll come back and answer minimum or maximum in a second. For graph B, what's your vertex?
3, 4.
3, 4. For graph A, is your vertex a maximum or minimum? Is it the lowest or is it the highest? Is it the lowest or is it the highest? Is this point the lowest on the graph or the highest point?
Low.
Okay, so would that be the maximum or the minimum? Minimum. Would graph B be the maximum or the minimum?
Maximum.
The domain for both of these is going to be the same. What would that be? Negative infinity to positive infinity for both. The range, however, is going to be different. For graph A, what's your lowest y value? And what's your highest? And then for graph B, what's your lowest y value? And what's your highest? For 7 and 8, we have to now find the equation that would match the graph. So in graph A, we know it faces up. So which two could we eliminate? and B. And then of A and B, which one do we think it might be? You can guess. A. So let's put A into our calculator, see if that matches. And then I'm going to actually graph it. Does this graph match graph A? No, it's off. So it's not A, it's B. And then for number 8, we know graph B faces down, so which two could we eliminate?
A and B.
A and B. Which of these two do we think it might be?
C.
Okay, so let's try C. Put that in and see if it matches. Does that one match graph B? No. So then which would be? I'm sorry. I crossed it. Alright. So then you guys are going to have time to practice. You could do one of the following. Either keep working in these notes, work on the Delta math as due today, your dividing polynomials, mixed factoring review. The graphing quadratics is due next week, but you can still work on it. Past Delta math, your JLabs, your SOL review that's due on Tuesday. So you have so many things you should be working on. Make sure you are using the time wisely.